Did you practice the questions?
Which ones? The one you sent me?
Yes.
Well, no, I forgot about that. I
You
had
f-
just started school again, so just getting ready for school.
okay. So you forgot to solve the questions.
Yeah, yeah.
So let's start doing it, or you will do it by yourself.
I'll do it by myself. It's okay.
Okay. So today, which topic are we going to study?
I don't know. I think,
Okay, let me see. Are we done with the probability?
yeah, we will do the probability tree and probability.
Yep. And we are not done with the probability even at the moment. Let me open the book questions. Uh, okay. There are two types of questions available in the probability. Okay.
Okay.
Two type of concepts are available basically. One is with replacement and the other one is without replacement. What I'm saying?
One's with replacement and one's without.
One without. What means that with replacement, if I'm saying that it means that if I have 20 balls in a
Yes.
you can in a box or in a bag.
Yep.
So I will see that while drawing one ball from the bag,
Mhm.
so I'll get any color. For example, I have three colors: yellow, green, blue. Okay.
Yes.
So and there are total 20 balls in that box, or in that, you can say that in that in the dress. Okay. So what I
Okay.
am taking? I am taking out one ball. What is the probability of getting each color? For example, 5, 5, and 10. 5 green. Let me write it over
Five.
here. Let me write it over here. Okay. Green are 5. Brown are 6. And
Yep.
yellow are 6, 5, 11, and 9. Okay.
Yep.
So what is the probability of taking yellow out of the
9
total?
out of 20.
9 out of 20?
20.
Good. But if I'll say that it is with replacement, okay, what I'm saying, it is with replacement. With replacement means that when I'll draw one ball from the ball from that, you can see that whatever is the box or container or wherever I'm putting all the total balls. So when I'll
Okay.
draw one ball out of it, then I will not put it back.
Okay.
So next time, how many balls will be available? 19 instead of
19.
20.
Okay.
So, and what will be the probability of taking a yellow ball? At
Um,
first, yep,
9 out of 20.
9 out of, not 9 out of 20, 9 out of 19.
19. 19.
19. So when I'll
Yep.
draw the third ball and I would like to have the probability of brown, what would be the probability of brown ball getting?
6 out of 19.
Not 19, 18.
Wait, why?
Because the 19th ball was already drawn out. So now it was
Okay.
not added back.
Okay.
Got it?
Yep, got it.
So what I mean to say, when we are saying that with replacement and without replacement, we have to be think in a reverse way. For example, with
Okay.
replacement means I am putting it, normally I put back, I replace it
Okay.
with replacement. But if I'm saying, and
Replacement.
I have to think that I don't have to add it back, And when I'm saying without replacement, it means I'll have to add it back. Means can next time when I'll draw at the ground ball, it would be 6 out of 20. Second time. When I'll draw the ball on the third time, it for green for 5 out of 20. So the total number will not be reduced. Okay.
Okay.
Any issue? Any issue? Ibad?
Yes.
Any problem?
Not, so wait. So every time, if it's without replacement, right, it decreases.
Without replacement, it will not decrease. With replacement, it will decrease.
Okay.
Okay.
Okay. Okay. Yep.
Okay. Mutually and non-mutually exclusive events. Fine.
Yep.
What does it mean? Mutually exclusive
Fine.
events means that overlapping of the events is possible.
All right.
For example, if you remember the lecture of sets, or even in the
Yep.
lecture day before yesterday, if you remember that the dice is having same numbers and the sum of two. So there was one event which was occurring, which was overlapping in between these two options. That was 1 and 1 on the same dice. Remember?
Huh? Remember.
Okay, so that was mutually exclusive event or overlapping event.
Okay.
Okay?
Yep.
That is, are there any outcomes that favor the occurrence for both event A and event B? So this is the outcome that was 1 1. So the rest of the five events was 2 2 3 3 4 4 5 5 and 6 6 on the two dices were not overlapping. Only one event was overlapping, that was 1 and 1 on both the dices.
This is okay.
Okay, any confusion?
Nope.
No, that's good. So if you are saying that there is something which is overlapping in between the two events is a mutually exclusive event. But if there is nothing common in between the two events, that would be non-mutually exclusive events. Okay, that would be non-mutually exclusive event. For example, uh, do you have the diagram which I shared with you
Yep.
regarding the sample space?
Yes. Yes.
Okay, just have a look at it and I will look in the diagram which I prepared, which I made on my register, and then I'll ask you. Fine. Uh, where it is? Busy, busy, busy. Okay, fine. Now look at the additions. Look at the sample space which I made for additions or even multiplications. But
Yep.
are you looking at it?
Yes. I'm looking at the sheet. Yep.
Okay, fine. So, if I'll ask you what is the probability of, likewise, probability of getting 3 in
Um.
some sample space,
Two. 2 out of 36.
and probability of getting same number on both the dices, is there any overlapping thing available in it?
No.
No. So it means they are non-mutually exclusive events.
Hmm.
Okay.
Okay.
And when I'm saying that thing, so this is the probability of A union B and probability of A intersection B. When the events are non-mutually exclusive events, not non-mutually, they are mutually exclusive events. It means the events are mutually exclusive. Probability of A O or B is can be written as or. Instead of or, we should use union.
Yep.
When I'm saying union, it means I'm assuming addition.
Okay.
Okay. When I'm
Yep.
saying union, it means addition. And when I'm saying addition, it can also be said as or. A or B, A and B. When I'm saying A and B, it
Yep.
means and means intersection.
Mhm. Yep.
Intersection or multiplication.
Okay.
Okay. So that
Okay.
is addition law of probability. For mutually exclusive events, that is probability of A union B is equal to probability of A plus probability of B. And the concept will remain same, that nothing is common in between them, mutually exclusive events. If A and B are mutually exclusive events, then probability of A union B will be probability of A plus probability of B.
Alright.
Okay?
Okay.
And when I'm saying that the events are non-mutually exclusive events, then the formula will remain little bit different, and the difference will be over here at this part. Okay, this
Yep.
part. So, and the difference would be I will have to subtract probability of A intersection B. I'll have to subtract the values which are common in between these two sets A and B.
Okay.
Okay,
Okay.
so over here, probability of king or queen. So is there anything common in king and queen?
Um, fifth, they both each have 4 cards.
Whatsoever. My question is there anything common in between king and queen? No. Other than that, these are picture cards.
Yep.
Other than that, these are picture cards. So nothing is common.
Uh,
Okay. Now probability
okay.
of ace and probability of king. Ace or king. So ace or king means or when I'm using the word over here or when it is
Yep.
demanded that you have to calculate the probability of ace or king, then that solution would be probability of ace plus probability of king. Probability
Mhm.
of ace in a deck of 52 cards is 4 out of 52.
Yes.
While the probability of king in a deck of cards, in a pack of cards, 52 cards, is 4 over 52. So while
Yes.
solving this, the answer is 2 over 13.
Okay. Yep. Makes
That's a
sense.
simple thing. Okay, neither king nor queen. I'm saying ace, neither king nor ace, or neither king nor queen. What is the probability of king or queen is 2 over 13. So what I will do, there are two ways that I'll have to calculate the probability of no king and probability of no queen. Another method
Mhm.
is I should simply subtract the probability of king or queen from number from 1. Why am I doing that? Subtracting it from 1.
Because all the probability they all add up to 1.
Very nice, very good. So you remembered that basic thing.
Yep.
When I was in intermediate and I was appeared in the paper, so there was a guy sitting next to me, and he did not prepare or did not study in his entire 2 years. So when he asked me the question, okay, tell me the MCQs of this, that sum of all the probabilities is always equal to less than 1, more than 1, equal to 1 or 0. So when he asked me, and that was his bad luck, when he asked me about this MCQ, I simply thought that if this person, this dumb person, has no idea about this answer, it means he has studied nothing. So he has no right to get pass. I told him out of 30 MCQs, I told him 24 or 25 or 28 wrong, and rest of the just two MCQs right.
Mhm.
Basically, this is the basic thing which you must understand, you must know. So that you should not make any mistake. Okay. uh, but that was my point of view of thinking. It is not sure that it is not mandatory that you should think in the same way. Okay,
Yeah.
so now what I'm saying now, we are moving on further to example or exercise to be 11 cards numbered 11, 12, 13, 14 up to 21 are placed in a box. A card is removed at random from the box. Find the probability that the number on the card is even, prime. Okay, what is the probability of even numbers?
So a half.
Not half. Count
Wait,
the
how
even
many?
numbers or write the numbers
Oh,
in your
oh, the
notebook.
even numbers. Oh, one, two, 5 out of 10.
5 out of
10. You have
11.
12.
11. 11.
What? You have 12, 14,
That's right,
16.
but the total numbers are 11, not 10.
Wait, why not? It's just
11, 12, 13, 14, 15, 16, 17, 18, 19,
oh
20, and 21. So the total numbers are 11. So 5 out of 11. What is the probability of having prime number?
um wait, I don't get it.
What is the probability of getting prime number?
No, but it's not. But it says 11 cards are numbers 11 to 21.
So
But
21. So you don't get this thing.
yeah, but it's 11 cards. But if you count them up to 21, there's only 10.
Count from start from 11. 11, 12, 13, 14, 15,
Never
16,
mind. Yeah,
17,
yeah,
18, 19, 20, and 21.
yeah.
If
Makes
that 11
sense.
number was not mentioned over here, then you were supposed to count from 12, 12, 13,
Okay.
14. Okay, but as 11 is mentioned over here, so you must add 11 in counting, total counting.
Now I can do it.
Sorry.
Now I can do it. I must find them down.
Fine, that's good. Now what is the probability of getting prime number?
I can. You have 4 out of 11.
4 out of 11. Very nice. So either even or prime.
So you do 4 out of 11.
Yep.
Add your 5 over 11, which is 9 over 11.
Very nice. And why is it 9? Basically, 5 are even numbers and
Yeah.
4 are prime numbers. 4 prime numbers are involved in it. So that's why
Yeah.
5 over 11 plus 4 over 11. 9 over 11.
Yeah.
That's good. Divisible by 3.
What? 3. No, 4, 4, 4. 4 out of
How?
11.
How?
You have 21, 12,
12, 15, 18, and 21.
18,
4.
21. 4. Yeah.
4 out of 11. Or neither even nor prime.
So you do 1 minus 9 over 11. So that's going to be
Very
2 over
nice.
11.
Very nice. Very nice. 1 minus 9 or 11. So that
9
will
over
be
11.
2 over 11.
11.
Fine. Okay. Mutually and the word exclusives are written on individual cards and the cards are put into the box. A card is picked at random. What is the probability of picking the letter U? Okay, there.
Um,
Yep.
3 out of how many letters are? So 1, 2, 3.
It is little bit different. It is little. This part is little bit different to solve because you have to see that how many times that each alphabet is appearing in mutually. That is, M is appearing just one time, so 1 factorial. U is appearing 2 times. L is appearing 2 times. So 2 factorial. Do you know how to solve this factorial?
Wait, which one?
Let me write.
It's 3 out of 64.
2, or let me say 5 factorial over here. Do you know how to solve this factorial?
No, I don't think so.
Okay, the factorial means the product of first five numbers.
Okay.
If I am saying 5 factorial, it means 5 multiply 4 multiply 3 multiply 2 multiply by 1. Even
Yep.
though 0 factorial is equal to 1. Okay, this is
Yes.
what you must remember, that 0 factorial, even though 0 factorial is equal to 1.
Yep.
Okay, so when I'm
Yep.
saying 5 factorial, what does it mean? 5 factorial means product of first 5 natural numbers, 1, 2, 3, 4, 5. If I'm saying 2 factorial, what
One
would be the
times
answer?
two. One
2.
times two.
2, 1 times 2. Okay. Now you have to observe the similar thing in this over here. So the answer would be 2 factorial multiply by 2 factorial multiply by 1 factorial and rest of the words. Okay. 1 T A Y M T A and Y. A card
Yep.
is picked at random. What is the probability of picking U? Individual cards. Letters of the word mutually and the word
Uh,
exclusive are written on
three out of
individual
six.
cards. So how
Three
many
out
U
of six.
are available over here? Three.
Three.
Three U are available over here. Okay.
Pardon?
So letter U, 3 factorial,
Yeah.
or what are the total numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So total alphabets are 17. So the
16 or 17.
17. What is the
So,
probability of picking the letter U? So 3 over 17.
yes.
And letter E,
Um, 1 out of 7. 2 out of 17.
2 over 17. Letter U or E?
Um, 2 5 over 17.
3 over 17 plus 2 over 17.
Yep. 5.
Okay. And a consonant.
Yeah. Wait,
What
what?
does it mean, a
Uh,
consonant?
a continent. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 17.
9 out of 17. And what are the
Yep.
consonants available over here?
M, T,
M, T,
L, L,
L,
X,
L,
X,
X,
T,
C,
L,
L.
S, I, V.
I is not consonant. A, E, I, O, U.
I can't do it wrong.
You just be very focused while
Yes.
solving. How many times I have to remember key? I have to tell you again and again.
Yep.
Okay, no issue. It happened. Uh, Fine. Mm.
Yeah.
Now, the letter U or a consonant?
So you have 8 out of 17
8 over 17.
and 3 out of 17, so 10 over 17.
10 over 17.
Yep.
Why?
8 out of, wait, how many consonants are there?
I'm asking just letter U or a consonant.
Oh,
So the
so you
letter
do
U is
3,
appearing 3 times. So that is 3 over 17
17,
plus
and
and 10.
how many?
10
Oh,
over
so
17.
13. Yeah, 13 over 17.
13 over 17. The letter U or E or L.
Yeah.
So what is the probability of getting the letter U or E or L? So it would be probability of U plus E plus L. So you will have to add it separately. U is 3 over 17 plus E is 1 over 17 plus L is 3 over 17.
Okay.
Isn't it?
Yes.
Fine. It means that you have now you have developed a clear understanding about how to solve this kind of questions. Okay,
Yes.
fine. So now let's come over here to this question number 7. In a basketball tournament, three of the participating teams are alpha, beta, and gamma. Probability of each of these three games teams winning the tournament are. This is the probability of winning. If
Winning.
alpha
So
wins, that is the probability 4 over 15. If alpha lose, that would be 11 over 15. Beta wins 1 over 10. Beta lose 9 over 10. Gamma wins 1
four,
over 5. Yes,
would it be 14 over 30?
14 over 13.
You have to have the same denominators. So you times it by 2, so it'll be 8 over 30. And when you do 1/5 times 6, it'll be 6 over 30.
6 over 13. Why?
Because if you need the same denominator, right? So don't you have to times by
That
6?
is a separate, that is the second story. What I am doing at the moment, I am telling you
Oh,
the way, I am telling you the way of thinking that how to solve this question. Okay, this is the success rate 4 over 15. So failure rate would be 11 over 15 for
yep.
alpha. For beta, where success rate is 1 over 10.
I don't know. Yep.
So the failure rate would be 9 over 10.
Oh, yes.
And gamma is 1 over 5. So the gamma, you can see that simple, the rate of failure of or probability of failure of gamma is 4 out of 5. So find the probability that alpha or gamma will win the tournament.
Um,
If alpha and beta are winning, then it means that gamma is losing.
I don't get it.
Sorry,
I don't get it.
did you get it or not?
Wait, so how do you answer the question?
You have already answered the question, but alpha and gamma 1 over 15 plus 1 over 5.
Um, 4 over 15, so you want the same denominator?
Yep.
So 4 times, you're going to times it by 2 for 4 over 15. So you have 8 over 30, add a fifth, times by 6. So you'll have 6 over 30, 6 over 15, 3 over 15, plus 4 over 15, which is going to be 7 over 15.
Okay. 4 over 15 plus gamma 1 over 5. So 3, 7 over 15. Fine. Okay. Alpha, beta, or gamma will win the tournament.
Um, so we'll have the denominator is 30. So will be 6 over 30 plus 3 over 30.
Okay, you must try it yourself. Okay, no issue. You must try it
Okay,
yourself, and I'll be sharing the solutions or answers of these questions as well with you.
okay,
Okay, so that you may check the answers as well.
okay.
Okay. In a game, Jun Wei attempts to score a penalty kick against a goalkeeper who will try to save his shot. There is an equal chance that he will score or miss his penalty kick. So 50-50 chances available.
Yes.
Okay, then John Wei has three chances to score the game ends once John Wei scores a penalty kick. So if the penalty kick is scored, then the John Wei wins.
Yes.
Draw a tree diagram to show all the possible outcomes. What is the total number of outcomes?
Um,
So do that.
can I, can I try to do it?
You have to make a tree diagram.
Okay, I'll try.
So either you will draw it over here on the screen if you are willing to. Are you willing?
I'm trying it right now.
Okay, you are trying to do it, but
Wait, I'm not sure. Wait, can you show me how it would look?
yeah, I can show
Is it
you. Or
6?
Yeah, I can show you. I can show you.
There's six outcomes.
Total six outcomes.
Yeah, is it?
Is it?
I'm not sure.
It is. It is. It is. It is.
Okay.
But let me make it for you. One when hit the first shot. Okay, when hit the first shot, three goals are there. Let's
Yeah.
say at first point it was win,
Mhm. Yeah.
and then it was lose.
Uh,
Okay,
yes.
win or lose. Again, when it win or lose, so at first point he lost it, so he again made a shot. Fine.
Yep.
Win lose, and then win lose. Win lose, win lose, win lose, and win. It six. There are total eight outcomes.
Mm, um, so you have win, lose.
Win lose, win lose, win lose, win lose.
I'm not sure how to do it. I don't get it.
You don't get it. Okay, fine. Just think over it. Likewise, head or tail. Remember that?
Yep, yep.
So first coin, first level, second kick, and the third kick.
Wait, so you want to separate them?
So sorry, separate
So you
them.
want to se Oh, okay, okay. Oh, can I try to do it now?
Yeah, make it.
That's what.
But maybe you won't be able to draw over here, and I'll have to go for the whiteboard first.
Okay.
So, but just make it on your copy, on your register, so that you should be able to draw it with your own help.
So there's three levels, right?
Sorry, pardon?
There's two levels.
Three levels.
Oh,
Yep. John Wei has three chances to score. Okay.
yeah,
John Wei has three chances to score. So if
yeah.
John Wei has scored in the first chance, it means that John Wei will win. But if she will not, then it means that she will lose and she will not score. So she will try the second time. It's just like penalty kick, boy.
Yeah,
According to this condition, according to this condition. So once the
yeah.
kick is already scored, Junwei has won. If she hasn't scored or he hasn't scored, it means the person Junwei will get another chance of kick.
Okay.
And if even in the second one, either Junwei will hit the mark or she won't. If
Okay.
she won't, then she will have another third option.
Oh, so that's why I have to do it three times. Okay.
Sorry. Okay?
That makes. I think I get it now.
Okay, now get it?
I think so. Yep.
That's good. Uh, Let me move on to next question. Multiplicative law of probability and independent events. In case of independent events means we are talking about mutually exclusive events. Okay? Nothing is common.
Hmm,
I am saying independent events means mutually exclusive events in which nothing is common.
yeah.
Sorry?
Yeah. Wait, what?
Got it?
Yep.
So if nothing is common, nothing is similar in two events, then I am saying multiplication law of probability. It means it is giving you and. The word will be used and for it. Which word will be used?
Yeah.
And A and D. But
Yes.
are you getting my point?
Not
No,
really.
not really. Okay. When I'm saying the word or use probability of alpha or beta, it means we are talking about union or plus sign. But
Okay.
when I'm saying and word, it means that we are supposed to multiply the probabilities. What we are supposed to
Multiply the probabilities.
multiply the probabilities, or we could use intersection sign.
Yeah.
But there is nothing common. We should not use the concept of sets which is used for intersection, that is common.
Yeah.
So that concept is not implemented over here in probability in the similar manner. So
Okay.
you should not be mistaken it.
Okay.
Okay?
Yeah.
Just like this sample space, if you look at it, first draw is 3 over 5 and second draw is 2 over 5. Not
Yeah.
first, second draw. That is first draw. So B and R, how many events are there? 3 over 5 for B and 2 over 5 for R. So
Yes.
again, if I'm saying for B, that sec for in a second row, so it is again 3 over 5 and R is red
Two
for
over 5.
2 over 5. So when I'm saying A intersection B, then I'll be multiplying 3 over 5 with 3 over 5. So that both the values are
Multiplying.
blue.
Wait, I did not multiplying.
Sorry,
I did not multiplying.
you didn't multiply.
I for the diagram. So you
Yes.
split them. You have three fish or you have two fish.
Yep. So we are splitting it because we are supposed to find out the probabilities and then use it.
Okay.
So while we'll be able to identify the probabilities, or you can say that until or unless you won't find the probabilities, you can't solve the answer. Exactly.
Yeah.
Fine.
Yep.
So first draw and second draw, this is giving you the values, but this is a complex structure in fact.
Yes.
Okay, so at first draw B's and the second draw R. So this is the thing basically.
Okay.
Okay, so B and R. So if I'm saying first B and B, so it means these are the 9 events for
Okay.
first B. So 3 into 3, 9.
Yep. Yep.
Okay, so over here in this example, and by the way, this chapter is already shared with you day before yesterday.
Okay.
Okay, so I shared with you this chapter on the day before yesterday, so you may find these things or try to understand these things if you will be solving it. In case you will have any kind of uncertainty or problem in it, just let me know. Okay,
Okay.
so that we will be clearing, I'll be clearing your confusions.
Yep.
Okay, so probability of B or into probability of R is B, and probability of R is 3 over 5 multiplied by 2 by 5, that is 6 over 25. Total number of balls in each draw.